This will be a calculus tutorial on continuity and how we can tell when a function is continuous. A function is continuous if we just think about drawing the graph of the function without picking up our pencil. Then we say that that function is continuous over the interval that we drew it. The precise definition, the mathematical definition, is this though. So a function is continuous at the point where x equals a if the limit as x goes to a of f of x is equal to f of a. So there's really three things here. The limit as x goes to a of f has to exist. F of a has to exist. And those two things must equal each other. So let me show you a quick example, an easy example. So here we will show f of x equal to 2x cubed minus x is continuous at x equals 1. So the first thing we should think about is, does f of 1 exist? F of 1 is 2 times 1 cubed minus 1, which is 2. And now, maybe we should show that the limit as x goes to 1 exists. So the limit as x goes to 1 of f of x is equal to the limit as x goes to 1 of 2x cubed minus x. And since this is polynomial, we can actually just plug in this value. So this is 2 times 1 cubed minus 1. Oops, 2 minus 1 is obviously 1. Is 1. And we note that 1 equals 1. So f is continuous at x equals 1. Okay. Good. So a little bit harder example. Okay, so how about this? Show f of x equal to 2x cubed plus 3 for x less than or equal to 0, and minus 4x plus 3 for x bigger than 0 is continuous at x equals 0. Okay, so we're going to do the same thing. So first, let's find f of 0. F of 0, well, where is f defined when x is 0? F is defined this way when x is 0. So we're going to have 2 times 0 cubed plus 3, and that's 3. So f of 0 is 3. Now we have to find the limit as x goes to 0, and we're going to have to do this in two parts, sort of, from the left and from the right, to make sure that the limit exists. So the limit as x goes to 0 from the left of f of x is equal to the limit as x goes to 0 from the left of, so the left of 0 we're defined this way, 2x cubed plus 3. This is polynomial, so this is going to be equal to 2 times 0 cubed plus 3, that's equal to 3. Okay, now, what's the limit as x goes to 0 from the right of f of x? That's equal to the limit as x goes to 0 from the right, minus 4x plus 3, minus 4 times 0 plus 3 is 3. And since the limit from the left of 0 is equal to the limit from the right of 0, both equal to 3, so the limit exists, and that limit is 3. And notice that f of 0 was 3, And well, 3 equals 3, so we are happy f is continuous at x equals 3. Okay, very good. One more example. Okay. So here. Find a such that f of x is continuous. And we're going to let f of x be equal to 1/2 x squared plus x for x less than or equal to 1, and ax plus 5 for x bigger than 1. So we're going to find the value of a that forces this function to be continuous at 1. So continuous, at x equals 1. So first, let's find, well, let's make sure f of 1 exists, right? So f of 1 is going to be 1/2 times 1 squared plus 1. And this is 1/2 plus, this is 3/2. Now, we want the limit as f goes to 1 to be equal to f of 1 equal to 3/2. So it should be clear, hopefully it's clear, that if we approach 1 from the left, it will be equal to 3/2. But we can show that. So the limit as x goes to 1 from the left of f of x is equal to the limit as x goes to 1 from the left of 1/2 x squared plus x. We substitute 1 in, since this is polynomial, and this is 3/2. Okay, now we're going to force the limit as x goes to 1 from the right to be equal to 3/2. So we're going to set the limit as x goes to 1 from the right of f of x equal to 3/2. That's what we're going to do. So, let me make some space. The limit as x goes to 1 from the right of f of x is equal to the limit as x goes to 1 from the right of ax plus 5. We can substitute the 1 in for x. Say this is a plus 5. Now, we want to set a plus 5 equal to 3/2. So all we have to do is subtract 5 from both sides. So our a value is going to be 3/2 minus 5, or minus 10/2, which is minus 7/2. So for our function here to be continuous, we let a be equal to 7/2, minus 7/2 rather. And that's it. So if you have any other questions about continuity, please feel free to email me, or any other questions of the mathematical variety, and hopefully I can post. Thanks a lot.